What's up, everybody? Welcome. It is time for our first lesson of AP Statistics. So I know we're all excited here. Definitely challenging year ahead of us. We're going to have to navigate, I think, expect to navigate some distance learning, blended with some in-person stuff. I'm really hoping we can, we can meet each other and hang out in class at some point. But we know that distance learning is going to be a big element to what's going on. And so this is our first piece of that. This summer stuff, this is the beginning of AP Stats. This is what we would learn if we were in our summer academy together in a normal year. So your job is to watch each of these 6 videos, take notes, and then use those notes to complete the summer assignment. Later in August, well, the week of August 17th, the week of August 21st, the week of August 17th, the week of August 24th, I'll be having some office hours on a couple days where you guys can pop in, video chat, say hi, right? We can introduce ourselves, but also, of course, I'm there to answer any questions, clear up any misunderstandings you might have about anything that's in these videos or in the assignment. And then ultimately, right, we want to make sure by the time we go back to school on the 31st, we know this content. We know what's in these 6 videos, and we're ready for a quiz on it in those first few days. But that being said, let's jump in. I am using a new writing tablet here, so bear with me a bit. I'll figure this out. Anyways, so here we go. So AP Stats, right? I already said that part. All right. So some quick business stuff. If you haven't done so yet, make sure you've signed up for everything for our class. First off, up here, we got the blog. So the blog is, right now, this is the #1 resource for our course. And in a normal year, right, this is the spot. So if you ever have a question, this is the first place to look. Post homework here, assignments, right, everything about the summer and office hours, right, that's all on the blog, so check that out. If you're not in my class, there's also, you might find some interesting answer keys or study guides, whatever, helpful resources, right? Feel free to check it out. So for us, please make sure you guys also sign up for Google Classroom if you haven't. I know most of you are in there. As we go through the year, we'll work together and kind of figure out what's best. Do you prefer if I use the blog primarily? Do you prefer if I use Google Classroom? Of course, Google Classroom, I can use the forms and you can turn things in. So that's a huge advantage, right, for the distance learning component, right? But as for which we use primarily or whatever, right, that's something we'll all work on together, right? You guys tell me what's best and that's what we'll go with. Got my email there, right? Email me anytime. Make sure you've signed up for Remind. There's our class code, right? You could do the text thing, but I like the app. It's free, and this is the way most of you guys communicate with me. And I've talked to many of you already. Right? If you're working on something, you need to send me a picture, and we can chat back and forth. So if you can, download the Remind app, and please, and if not, right, use the text version. Text that code to 81010, or download the app and enter that code. And then I mentioned some stuff about the office hours. So it's all the business stuff. Let's jump right in. So our first lesson here, intro to data. So we're not going to do any kind of groundbreaking math in this. As a matter of fact, I really want to use this lesson. The content's important. We're going to have a lot of vocabulary, but I really want to focus on your note taking. So it's super important that you take good notes this year. Our notebooks are going to be one of, probably our primary resource when we're working on multiple choice and free response or whatever in class, figuring stuff out, right, when you're home on your own. So it's super, super important that you have an organized, right, well-structured notebook. I don't necessarily care what kind of notebook you use. You do what works for you. If you buy like a single subject 70-page notebook, like you're definitely going to fill that up. Maybe in the first quarter, there are a lot of notes in this class. I personally wouldn't want to have multiple notebooks, so I'd go with the bigger one. You go with a 3-ring binder, right? That seems to work well for a lot of students. There's going to be a lot of handouts and free response, so that might be your best option. But you do what works for you. And then the other thing I'll mention is I like to do a lot of color coding. So when we're in class, you'll see me doing that on the board as I structure and organize things. But I challenge you to color code your notes, and I like that for a couple reasons. One, it'll make you pay attention to your note taking a little more and be a little more deliberate in what you're doing as you consider what colors you're using and why, right? So not just like random nonsensical color coding, but maybe you color code examples one way and definitions one way, whatever. Color coding also can help us to deepen our understanding of the content, right, of the vocabulary, because as we color code certain words or things, right, as you put all of something in one color, right, it kind of makes us think about the connections between those, like why are these things all red, or why should, which one should I make red, right? So it can help us with our conceptual understanding, I think, a little more as well. So those are some little tips there. But anyways, jumping in, right? So if I'm starting up my notebook, You know what's the worst thing ever? A bunch of loose pieces of paper. So if you have that, you should either stop this video and go get a notebook, or you're in future and then copy all this stuff into your notebook so it's all in one place. But anyways, right, so like if I have my notebook here, right, so we're talking lesson 1 here for the summer, intro to data. When we're in school, they won't be by lesson number, right? They'll be by topic, but whatever. And so first question is, what is data? And so that's going to be our first term. So data, what is it, right? And then maybe I'm writing my definition here. So data is information. Data is any systematically recorded information, right? It's recorded intentionally with a purpose, with its context, right? So it's not just a page of random numbers, but it's got to have that context, right? It's got to have like, what is the information? What is that data about? So data is any systematically recorded information, numbers, or labels with context. I'm sure a lot of us picture, numbers primarily, right? But it could be anything, right? It could be your political party or the high school you went to or what degree you have or whatever. And you see that word context there in red, and that's an important word. You're going to hear me say context like 372 billion times throughout the course of the year. Anytime we're analyzing data, we want to consider the context that it's about and how it was collected. And then when we start to work with our free response questions and stats, anytime we're writing anything in this course, it's got to be in context. So we're never going to write about the data or the distribution or the graph, right? We're going to talk about the household incomes of East Hartford residents or the 40-yard dash times of New York Giants players, right? Everything we write has to be in context. So when we say context, we're thinking about the who, what, when, where, and why. So who's the study based on, right? Is it based on adults? Is it based on kids? Is it based on whatever, plants? I don't know, right? So who is the study based on, right? And so the respondents, experimental units, subjects, participants, that's just some specific vocab that'll come up in a full unit we have about data collection, right? Are we talking about respondents to a survey? Are we talking about experimental units like plants or whatever in an experiment? Or are we talking about some subjects or participants in some experiments and volunteers, whatever. We also want to consider who conducted the study. Right, although stats should be done right impartially with no bias, just like science, right? We know that every organization has their biases, and so we want to think about who might be conducting a study. We know places like Quinnipiac University is a big polling organization, or Gallup, or the Pew Research Center, right? And we know those are all reliable organizations, right? So who's conducting the study? We also want to think about what are we measuring, right? What are our variables? What's our data? We want to think about when was the study conducted, right? If we're talking about incomes in 1950, that's a lot different than in 2020. We want to talk about where, right? Similarly, right? Where is important. Things are different in different places. We want to think about why is the information being collected? What was the intent of this study? And last, we want to think about how the information is collected. It's important in statistics. The most important part is how we collect our data. If we don't collect our data appropriately, and so later in the year, we'll have a unit about how to collect data using surveys, using experimental design, using observational studies, and we'll talk about how to randomly select a sample, right? But how we collect our data is really the most important piece of the statistical process, because if we don't collect our data the right way with randomization, then all the math we're going to learn how to do afterwards is irrelevant, right? All the math's meaningless if it's based on flawed or biased data. And so when we say context, that's what we're thinking about, right? Kind of the whole picture of what the situation's about. All right, so let's think about the types of data that we can collect. By the way, side note here, let's see, hold on, sorry. When I took my notes, I chose to got my definition in black there, and then I boxed that word context in red, right? Chose to kind of list what that was about. But you don't necessarily need to write down every word. Don't just mindlessly copy down a PowerPoint. That's not learning anything. And now I jumped in with some blue here because now we're going to start to look at an example. So let's do that. So, sorry. No difficulties. Oh my God. course, I'd much rather be in class doing this, but that's not the deal. So types of data. Let's imagine you're going to survey some East Hartford residents, ultimately trying to gauge, people's opinions about their living experience, the cost of living, standard of living, right, whatever, how much they like East Hartford, anything, right, overall information about their living experience. And so you're going to survey East Hartford residents, but you're going to record all sorts of different pieces of information about them, right? You're going to collect all different types of data about the East Hartford residents. And so the first thing I want you to do is pause the video here and try to come up with a list. What are some of the variables you would measure? What are some of the pieces of data you would collect about East Hartford residents? And you're thinking anything that might be related to the overall living experience for an individual in East Hartford. Now, in a perfect world, we would, I'd tell you to turn and talk to your neighbors over there, talk to a group, you'd share these out, bring some of them on the board, but you're on your own. Try to come up with a list, as many as you can. Go. All right. So now as you're looking at your list, right, we're sharing stuff out to their age, where they live, what street or neighborhood. As you're thinking about this stuff, maybe you came up with some ideas like this, right? So we've got age, race, household income, political party, religion. That age, race, religion, right? Political party, right? That's pretty common in lots of stuff. You see some of that stuff on the back of your SATs. Maybe you put like ethnicity, right? Maybe you're literally just picturing the back of your SATs, what language they speak. I don't know. Right, so here's a sample list, right? So as you're looking at this, along with whatever ideas you came up with, what I want you to do now is I want you to take, right, your variables, and I want you to put them into two categories, however you think you should do that. So I want you to put them in two groups. The only rule is it's got to be two groups. So take a minute, right, and try to group your stuff into two different groups. Now, as you're looking at this, right, so now, unpause. I'm pretty confident that if we did this in class and I had you talk to your neighbors and stuff, probably most groups would put these into two groups based on similar criteria. And I think, I'm pretty confident, right, I've taught stats a couple times, but I'm pretty confident I would see something like this. All the purple stuff, one group, and then we got all the yellow stuff, another group. So purple group, yellow group. Now, as you look at this, think to yourself, did you group yours? Well, two things, I guess. One, how are these grouped? Like, why are all the purple ones purple, and why are all the yellow ones yellow? And then two, did you group yours the same way? Right? And do yours kind of follow that pattern that you're identifying with the purple group and the yellow group? And I feel pretty good saying that I think a lot of us would do this, and a lot of us would realize that this yellow stuff here, right, these yellow variables, these are all categories, right? A yes or no answer, or right, your political party, right? You're gonna get some label, Democrat, Republican, Independent, whatever, neither. Education level, we might think like high school diploma, bachelor's degree, associate's degree, whatever. And then the purple stuff, right? Those are all numbers, right? So we've got how many kids you have, right? These are all measurements of something. How much does your living cost? How much money do you make? How long you've been on Earth, right? With your age. And so this leads us to the two types of data that we're going to work with throughout the year. We've got the yellow, the categorical, or also known as qualitative data, and then we've got the purple, the quantitative data, right, the numeric measurement. So as we're moving forward here, let me just jump over to my notebook one more time. For me, you can see I chose to do an example in blue, right, because it was an example, so it was a different color, whatever, right? When you think about how to color code your notes. So I kind of just summarized the context, and then you can see, right, I've got all the green ones. Those are our quantitative variables for me. And then I used some red, or maybe using highlighters, whatever. I just want you to think about color coding your notes strategically. Those are our categorical or qualitative variables. Now to finish this up, we got a few slides. Here's what we're going to talk about next. We're going to look at each type of data, its definition, and we're going to look at graphical displays for it and summary stats. So what I would recommend in your notes is to create a little table. So categorical data, leave some space for a definition. We're going to list the kinds of graphical displays we can use. We're going to list the summary stats we use to summarize categorical data. That's not how it's going to show up in my screens, in my slideshow, because I didn't want to put so much information on one slide, but right, that's what I would do. And then we're going to do the same thing for quantitative data, right? Leave some space for a definition. What displays can we use? How can we summarize that data numerically? All right, so let's do that. So, categorical data. Categorical data is what it sounds like. It puts stuff in categories, right? So it sorts data into groups or categories using words or numbers. One thing to be careful of, right, is you can't just think every number is automatically quantitative. So we could use numbers categorically. Right, so if a number is not measuring anything, it's grouping someone, right, then it's just categorical. So for instance, your grade level, and also some variables can be both. Your grade level, right? We could use 12 categorically and just put that into a group, right? That's essentially, if we're using grade level 9, 10, 11, 12 in that way, just putting you into a group, that's the same thing as saying freshman, sophomore, junior, senior. Or we might consider grade level 12 to be a measurement of like how many years of education you have or something like that, right? In that case, we're using that quantitatively. So a variable can be used both ways. It depends on the context, depends on the intent of the study and how the data is being used. But another example I'd like to give real quick, right, is like your area code. So this is, right, just showing where what the area codes are in Connecticut. When I was growing up, there was only 203 and 860. But anyways, right, that 860, that doesn't like measure anything, right? That's not a measurement about you, but it puts you in a group. It tells us that you live in that blue part of Connecticut that you see, right? So there's an example of a number that's used categorically. But anyways, so categorical data, qualitative data. Just picture for yourself, if you had, right, like if you had a bunch of information, categorical labels, right? You had a bunch of political parties, right? So you had a bunch of Democrats, right? And there's like 31 of those. And then you got like Republicans, and there's like 26 of those. And then you got a bunch of independents. And I don't know, there's like 18 of those. And then other, right? Other parties or something. There's 7 of those. Think to yourself, what kinds of graphical displays could you use to summarize that data set I just made up there in red? So you have a few options, and I really wish we were in class so we could share some ideas on how to talk to our neighbors and all that. But hopefully you're doing all that stuff on your own. That's a key element to distance learning. For this to be effective for you, you got to be engaged independently. And so it might seem silly, but when I'm saying pause the video and brainstorm, talk out loud, right? Whatever, talk it out. But you got to do those things that you maintain engaged in these lessons. And I know it's hard. It's hard for all of us. But anyways, what are some graphical displays, ways we can summarize categorical, also known as qualitative data graphically? And I'm thinking hopefully some of us said our good old friend, the pie chart or the pie graph or whatever you want to call it. Maybe you were thinking a bar graph would be a good option. Maybe you were thinking, that's probably all you were thinking. I don't know what else you got. Maybe you were thinking like a line graph or something. That's kind of just like a bar graph but connecting the tops. This actually right here is called something itself. So if I just turn that into a little table, that's what we're going to call a frequency table. Right, so a frequency table, that's this over here. It's just a table showing each category and what we're going to call the count, or the number of things in each category. Then the only other things we're going to add is we're going to throw the word relative in front of a couple of these. So we can talk about a relative bar graph or bar chart. And we can also talk about a relative frequency table. And so when we say relative, that means relative to the whole group. Or in other words, when we say relative, why is it impossible to pick a different color? When we say relative, really all this means is we're going to use percentages instead of the raw counts. So if I make a bar graph, right, where this is the number of Democrats, right, whatever, there's however many Democrats and however many Republicans, right? If I use the raw number over here, we call that a regular old bar graph. But if instead I use the percent, right, by doing 31 out of whatever the total is, let's see, 30, 57, 67, 75, right, 31 out of 82, probably should have planned this example ahead of time so the numbers work nice, right, and I find this percent, right, and I put the percent on this axis, then that's a relative bar chart. If I put the raw count right here, that's a frequency table. But if instead I change this to percent, right, and find all these percentages like I did in blue, that's called a relative frequency table. So no big deal. So relative means use percentages. And on that note, let's think about how we can summarize categorical data numerically, our summary stats. And those are both on the board right here. We got two options when we're looking at categorical data. We can talk about the number of things in each category, which we call the frequency or the count, or we can talk about the percentage or proportion of things in each category. All right, and so I'm going to jump ahead here, and I should probably clear all that out so you can read everything. You can pause if you didn't like my sloppy handwriting. That's all those graphs and relative. So we've got the count or the frequency. These are our summary statistics. So how do we summarize categories with numbers, right? So we want to look at two ways, how we summarize the graphs and numbers. You use the count or frequency, just how many things are in each category, or the proportion or percentage, right? This is just telling you how to like find a percentage, right? The number in the category out of divided by the total sample size. So in this class, side note, anytime we say the word proportion, that's just a fancy word for percentage, right? So if I say proportion, you give me a percentage. That's that. All right, quantitative data. So quantitative data is a bit different. So here you got to think about, let's say we had like a bunch of test scores. So quantitative data are any numerical values that measure something. One thing to pay attention to is there's typically going to be units with quantitative data. Now sometimes they're like a little hidden, like test scores, the unit would be points, or age, right, years. But like number of children you have, like the unit is just number of children, right? Like one child, I have one son, his name's Lincoln. Anyways, so it's a quantity, right? It's a measurement. So let's say we have a bunch of test scores. So 37. Why did I start with that? That's a horrible test score. Don't do that. But anyways, things happen. Maybe that person didn't sleep the night before. 84, or more realistically, didn't study. 93, here's the studiers. 89, oh, don't study because whenever I study, it doesn't help. No, that just means you didn't study effectively. Don't ever bring that garbage into my classroom. I didn't study because it makes me do worse. No, it doesn't. It definitely doesn't. Anyways, all right. 84, 86, 67, didn't study. 82, whatever. How could you make a graph of those numbers? What are your options? All right, so take a minute, pause this bad boy, and see what kind of list you can come up with. This is probably a bit harder. So we won't spend a ton of time going through categorical displays, right? Like I expect you to, I know you know how to make a bar graph. We're not going to break out any protractors and make pie charts. You just gotta know how to read it, so I'm not worried about that stuff. But we will spend a good amount of time looking at how to display quantitative data. And actually the next video will be about histograms, and we'll be one about box plots. And so those are two of our options right off the bat. Some of you, maybe some of you took stats in the first quarter of geometry last year. And so you were exposed to things like histograms and box plots. But maybe you didn't, because that was new last year. So maybe you're a senior, I don't know, whatever. Maybe you didn't take geometry and you didn't learn this stuff. No worries, that's what the videos are for. So we got histograms, we got box plots, we're going to have dot plots. That's going to be pretty simple. We'll take a look at those. Our good old friend, the stem and leaf plot, or what we're going to call the stem plot, because I'm too lazy to write stem and leaf. We're going to have something called an OGI, which is like a cumulative frequency plot. And so these displays, I expect we have a lot less familiarity with, except maybe some of us have seen the histograms, box plots, maybe stem plots at some point, maybe in science, I don't know. Right. But I'm going to kind of mix everything up, but we will focus, right, in one entire chapter on these graphical displays. And there they are, but neater. Relative frequency histogram, sorry, I forgot that. That would just be, again, just using percentages rather than frequencies on the left side. And we'll talk more about that in the histogram video. And then similarly, if we have a bunch of test scores, right, how could we summarize those numerically, right? So I forgot the numbers, right, 87, 37, whatever, 59, 95. So again, if you have a bunch of test scores, how might you summarize a bunch of numbers numerically? And this is additionally split. You don't necessarily have splitters, right? But I'll do two different colors, right? So there's going to be two categories here. We're going to talk about, sorry, I'm going to go with my green here. So we're going to talk about measures of center and measures of spread. That seems like it should work. So we've got measures of center, measures of spread. What do you got? Measure of center or central tendency. That was crazy. So for center, those are the ones you guys know. We've got our good old friend, the mean, or the average, right? We can find the average of all these test scores. We can find the median, right? That's the middle number in the data set. Don't forget to put them in order. We could find the mode. For us, we're going to use mode more as a descriptor of the shape when we make a graph, but the mode is a measure of center, or we could calculate something called the mid-range. And the mid-range is the middle of the range. It's the maximum plus the minimum divided by 2. Now in our class, we're really going to primarily focus on these two. These are our best options for our measures of center. And so later in this course, right, in the next couple, whatever, first few weeks of school, we'll start to explore the measures of center each individually in more depth. And we'll start to talk about, like, why do we prefer the mean and median over the mode? In our old books, that's chapter 4, right? So measures of center and, numeric measures are all in chapters 4 and a little bit of chapter 5. Measures of spread, one you guys might have guessed, and again, for some of us from geometry, maybe we know some of this, right? Some of us might be familiar with the range, right? Which is just the max minus min. The range is one number. The range is not 37 to 97. The range is 60, right? You have to actually find that difference. Then we've got something called the IQR, the interquartile range. That's going to come up when we start to make box plots. Some of us, again, maybe some familiarity, maybe not. Excuse my horrific handwriting. And then we're also going to have the standard deviation. And so in chapter 6 of our book, we start to explore the bell curve, and that's where we'll get really heavy into exploring the standard deviation more deeply. So here we're kind of laying out the big picture, right? These are the ways we can summarize a set of numbers graphically and numerically. Numerically, we have measures of center and spread, so there's a lot going on with quantitative data. And our first unit of this course is to get into all this stuff, right? How do we make all these graphs? How do we, it's not about computation, right? It's not how do we find the average, that's whatever, that's simple arithmetic. But it's when is the average better than to use than the median? When is the IQR the best measure of spread versus the standard deviation? Why might the range be unreliable sometimes? Why might the mid-range be unreliable sometimes? So all those conceptual questions about these graphs and about these measures of center and spread, right? That's all what's coming up in the beginning of this course. So if you're looking at this list and you're like, I don't know what standard deviation is, don't panic, not a big deal, right? We're gonna figure all that out together. All right, so let's see here. What's next? I think that's it, man. I think we're good. So there's all that stuff I just said. Oh, variance, which is just the standard deviation squared, right? Not a huge deal. You know, we'll talk about that later. So use these notes. There's a couple basic questions about types of data and stuff on your summer assignment. I might even check your notes when we go back to school. So hopefully you got a beautiful notebook. And if you want a little more challenge, let's take a look at this. This was supposed to be the warm-up in the beginning, but I skipped it, and then I didn't want to go back and redo the whole video. So if you're looking for a little challenge, this would be our stamp problem in class. We'll talk about what that means, like a warm-up, exit slip, whatever. What do you think? Come see me in office hours sometime. We'll see if you got the right answer. Or send it to me and remind. Have a great day, everybody. Except now I'm clicking stop share. Now have a great day, everybody.